start this thing. The test is on Monday. No test this or quiz this week.
Quiz this week?
No, what did I just say?
You said quiz.
I said no quiz this week. The test is on Monday because we cannot have a test on Thursday because it's all reserved days. So the test has, well, either the test is tomorrow or on Monday. And I don't think we're having the test tomorrow, are we?
No.
With half the class taking AP US history.
How much for the next day?
Wait, time out. Is AP US history in the morning or afternoon?
Morning.
Oh, no problem then.
Oh no, can I have
We're
Then
just
no.
gonna have it Monday.
No
I
test.
can have this tomorrow.
Anyway, the only reserved days for math are tomorrow and Monday. Because after that, it's SAC review days. You guys know what that is, right? SAC.
Semester accumulation.
Student. I don't even know what it means.
Assessment course.
Okay, this is your course evaluation, which is due next week Friday.
Is it credited?
Well, just read it.
Wait, do we have to put our names on?
You don't have to put your name. Who's absent? Who?
Can we get the B curve on the semester exam?
So it's a single spaced essay.
Essay? 0.6666.
It's always been that in PCH.
What is it? Essay?
Yeah, that's for that. No, it's very cathartic when you write it, you know.
We have 26.
Just do it. Answer all the questions that's there. It's not like you have to sit there. It's not like you have to sit there. What do I write? I'm telling you what to write. Like, what was your effort? Right there. Right? And then, what did you think about the course? What about the homework? Was too much?
Wait, there's an adjustment.
How many times you didn't do it on time? Quizzes, tests, graphic calculator, textbook, worksheets, video, Google site. Yeah, so I'm telling you, just like write a couple sentences for each one, you got a whole page right there. And then if you don't hand it in, then you're not going to get adjustments on your semester exams. Now, do you guys remember your first semester exam? Remember I told you I made an adjustment to it? That formula I came up with?
To raise it to the 0.66 power.
No, it was a different one. But there was an adjustment, but you don't hand it in Friday, and if it's like not in the form it's supposed to be, you're not going to get any adjustment. You just get whatever your raw score was, and same thing for the second semester exam, just to get whatever. For some of you, 42 and then 41. If you want that to be 20% of your grade, then let it be, yes.
When is the math final exam?
Like Thursday.
It's the last day, I know. What's the last day?
It's like Tuesday, Wednesday,
Thursday?
What's Tuesday?
Why, what are you planning to do?
Oh no, I just wanted to have to study for
History.
What's the study? History and language.
Okay, we know what's going on now. Okay, I'll give you 15 minutes to ask questions. So this was like the practice test now. This is what we're gonna do. We're just gonna learn as much calculus as possible until Friday, and then that's what's gonna be in the test on Monday. K through R, forget that. Okay, number 4. Oh, boo. Guys. Okay, I'm not going to write this out because this is too much writing. Now, if you were to graph this ugly radical function, you know what you would get? You would get a graph that looks like this. There's like a removable discount. There's a puka there. Okay? And then when k, it says k when x is 3. So when x is not equal to 3, it's equal to this graph. But when x equals 3, what does k have to be so that the function will be continuous? Now, what does continuous mean to you? Last year, they brought that up. There's no, not just removable discontinuities, but there's no breaks in the graph. Like, that's a break, right? If somebody were to ask you, is this continuous? No, because there's a break there. What about this? What if you had a graph that had a vertical asymptote like this? Is the function continuous right there? No, because there's a break in it. What about the graph that looks like this? What if the graph look like this? Is this graph continuous? No, because there's a break there. Any kind of break, that means the function's not continuous. What about this? Is that continuous? Yes, because there's no break. We learned this term last year, come on. So, the question is asking, what should the value of k be so that it will be continuous? In other words, the y-coordinate k has to be the y-coordinate of that point, because if it's not, then if it's something else, is that continuous? No. So the only way it can be continuous if k is equal to the y-coordinate of that removable discontinuity. So now the question is, how do I find the y-coordinate of the removable discontinuity? What are we learning in this chapter? It rhymes with limits. The limit! You compute the limit as x approaches 3 of this function, which is, I guess I gotta write it out. Root 5x plus 1 minus root x squared plus x plus 4 all over x minus 3. Because, what does the limit tell you? If it exists? Yeah, that means it's coming to the same point from the left and the right. And doesn't the limit tell you the y-coordinate of that point? So if we compute the limit of this function, it's going to tell you the y-coordinate of that point. And that's what you want k to be, to make it continuous. Oh boy, we're in trouble. What's a limit? So, how do we compute limits? What did we learn last week? What's the first thing you do as x approaches a finite number? Plug in the number. Now what happens when you plug in 3? You get 4 minus 4 over 3 minus 3. 0 over 0. What do I do? 0 over 0. What do you do when there's radicals? You multiply by the conjugate. There should be no, come on. At this stage, when you see the radical, you know you're going to be multiplied by conjugate already. Okay, so multiply top and bottom by the conjugate of the radical expression. Now, what happens when you multiply this out right there? What do you get? You get 5x plus 1 minus x squared plus x plus 4. Now, can that be simplified? You bet your sweet pippy you can. That would be negative x squared plus 4x minus 3. Can that be factored? Yes, that comes out to negative x squared minus 4x plus 3. And that is negative x minus 1, x minus 3. Can I do any canceling? Yes, this cancels that. So the only thing that's left now is this over this. Now can I plug in 3 and get something?
Yes.
Okay, if I plug in 3 there, what do you get? No, what? Negative 2 over, and what happens when I plug in 3 here? 4 plus 4 is 8. So negative 1/4 is the answer. So that means the coordinates of this removable discontinuity are 3 comma negative 1/4. So what should the value of k be so that this function is continuous? Negative 1/4. Because then it fills in the puka. And you don't have the puka anymore. Oh boy, we're in a heap of trouble. Okay, number 5. Again, you got to know what continuous means. Except now we have a piecewise function. Okay, Garen's barbarians, these 2 problems are on the test. You don't even have to ask. Well, the test looks kind of like this, except you got to learn about the derivative today. Okay, now this is a piecewise function. There's 3 pieces. Okay, negative 1 and 2. See, this is where the first 2 pieces meet, and this is where the second and third piece. In order for this function to be continuous, like this, is this continuous? Oh, like that. Is that continuous? Yeah, because there's no breaks. I don't see any breaks. What about this? Is this continuous? No, because there's breaks in it, right? So the problem here is, what do the values of a and b have to be so that this function will be continuous like that, there's no breaks in it? Well, can you see that the first and the second piece meet when x is -1? See right there? So that means when x is -1, doesn't the y coordinate of the first piece and the y coordinate of the second piece, what can you say about it? They have to be equal. Otherwise, if they don't touch, how is it going to be continuous? So if you plug in -1 here and -1 there, you got to get the same value. So plug in -1 here. -a plus b. Plug in -1 there. -1. In order for the function to be continuous, they have to be equal. Otherwise, they're not going to touch. Otherwise, it's going to look something like this. You guys understand that? The y coordinate of the first piece got to equal to the y coordinate of the second piece. Otherwise, they're not going to touch. It can't be continuous. Now, where do the second and third pieces meet? When x is 2, right? See 2. And same concept. If I plug in 2 here and 2 there, they have to be equal so that the two pieces actually meet. So plug in 2 here. 8. Plug in 2 there. 2b plus a. They got to be equal. And then, can you guys solve for a and b? Yeah, just add the two equations and you can get b already, right? I'll leave that up to you. So it's actually pretty easy, that problem. And then k through r. Okay, you guys got 5 minutes. You guys better pare that down, k through r. Especially k. Doesn't that look like the problem we did before in the homework? Yeah? Then how come we can't do it if we did a problem just like it? No. Oh, and everybody here could do I. Oh, I see D now. Okay, let's do D first. Some of you, I think you guys just took a holiday. Should I come around and look at your homework right now? Or are you just gonna admit defeat? Haruoka?
Oh, I'm not sure.
I keep telling you guys, you're on a trip, you're responsible for what happens in class.
Oh, but the Wi-Fi wasn't working well, so I didn't get
You
to
guys
read it.
came back Sunday.
I had to write a 5 to 6 page paper.
What about Monday? What about yesterday?
And then I had a 2-page English paper and 2 labs.
What? Why not just do this until your teacher? Oh no, I had math homework.
Because I was stuck after the first worksheet because I couldn't watch the video.
Okay, what's the first thing you do when you compute a limit? Plug in the number. Now, some of you I know are not even plugging in the number. You don't plug in the number, you're done for on this. Because otherwise, how do you know what to do? Okay, plug in 0. What do you get? Okay, if you cannot plug in a number, just give up this. Just give up this test. Right? 0 over 0. Oh, what does that mean? It means I gotta do something. Simplify. Look for friend. Multiply by conjugate. Use power series. Do something. Okay, there's 2 things you can do. You can either look for friend by multiplying top and bottom by the conjugate, or you can use power series. I'll tell you right now, power series is the easiest. Okay, what's the power series for cosine of box? 1 minus box squared over 2 factorial plus box to the 4 over 4 factorial, and so forth. What happens when you distributize this negative sign? This is minus, that's plus, this is minus, the next one's going to be plus. And the ones cancel out. And then now you just lift and separate. Okay, what's this over that? Hey, this is 9x, okay, this is 9x squared over 2, and you divide that by x squared. Okay, let me write it. 9x squared over 2 minus 81x to the 4th over 24 plus whatever. Okay, what happens when you divide this by x squared? You get 9/2. Now, for those of you who've been doing your homework, you know that's going to be the answer already, right?
Yes.
What are you talking about? Okay, now go this over this. Minus 81 24ths x squared. Plus, then you're going to have some number x to the 4. Minus some number x to the 6. But it doesn't matter what those numbers are. No, because look, what happens when you plug in 0 for x now? This is 0, this is 0, this is 0, 0, 0, 0, 0, 0. What's the only thing that's left? 9 halves, that's the answer. When you do power series, people, whatever's the first term, that's the answer. But Hanoka, only now you're figuring this out, right? Since you have English papers to write.
It's beautiful.
Yeah. Now this is the ridiculousness of period 6. Mr. Park, do we have to write limit on every step? Only if you want full credit. Hello. Because as you're going to learn today, there's a big difference between the thing with the limit and without the limit. See how I don't skip? I write limit on every step. Now please don't write limit on this step, because when you actually plug in the 0 for the x, then you're applying the limit. So this is just the answer. Because every year there's always people writing limit. I mean, that doesn't even make sense, because okay, that doesn't even make sense either. It's just 9 halves is the answer. The answer is 9 halves. That means as x gets closer and closer to 0, this thing gets closer and closer to 9 halves. That's what this means. Should I do I? I think I better do I. I think I better do I. Even though you didn't write it on the board. Some of you just looking at for the first time right now, right? Okay, look. If I plug in 0 for x, no, it's 0, Mr. Park. 0 times anything, 0. No, except we have a problem. This is getting closer to 0, but that's going to infinity, right? Because cosecant of 0 is undefined, right? So this is 0 times infinity. That's also indeterminate. We don't know what that is. So what do? I see a trig function there. Should I use power series or look for friend?
Change everything to sine.
Yeah, this is friend, people. So does anybody know the power series for cosecant? I don't think so. Yeah, well, what do you mean friend, Mr. Park? Well, isn't cosecant 1 over sine? So isn't that this? Now can you see friend? Yeah, but Mr. Park, he's upside down.
There's a pi there.
Friend is standing, he's doing a handstand. Well, then huli him or her. Like this. Huli. Now can you start to take shape? Do I see friend? Yeah, but Mr. Park, I thought you told me friend was sine box over box. Yeah, that's sine box, but so in order to get sine box over box, what do I have to put next to the x here? Pi. So how do I do that? Just put it. We did this last week, people. You multiply top and bottom by pi, because that's legal. So now I have sine box over box, but that still doesn't guarantee it's friend. In order for it to be friend, the box got to get closer to 0. It doesn't matter what this is, the box got to get closer to 0. And does it? As x gets closer and closer to 0, does the box also get closer and closer to 0? How do you tell, Mr. Park? Well, think of a number very close to 0. 0.000000001. Plug it in here. What's pi times 0.000000001? 0.0000000 pi. Is that close to 0?
Yeah.
Yes, so this is friend. That gets closer and closer to 1. That's friend. So what's pi times 1 to the negative 1 power? 1 over pi. There you go. That's the way. That's friend. See, some of you are just befuddled. You know why? You're not doing the homework. Why am I looking at you?
Friend goes to 1.
Wait, let me look. Yeah. Friend, that's like the most important thing we learned.
No, the videos weren't working. I promise you I was
Yes,
right there.
on the big island or whatever island you were on. But on this island, it was working.
It's okay. I haven't checked it yet.
Okay, we got time for 2 more questions because we have a lecture today, people. Choose it wisely. Okay, K, we did a problem like that already. Complete the square, remember? And then make a piecewise function. Okay, I will do L. I'll pick the problems then because you guys have no idea. Like I said, some of you just looking at this for the first time. What is this thing, Mr. Park? What's that?
Greatest integer.
Okay, I'm just going to give you a secret. Okay, the easiest way to handle the greatest integer function is to plug in a number very close. That's the easiest way. So As x approaches 2 from the left, what's a number very close to 2 on the left? 1.99999. Okay. What's the greatest integer of 1.99999? 1. And what is 1.99999? And then subtract that from 1. What do you get? Negative .99999. What number is that close to? Negative 1. That's the easiest thing to do. I was going to have you draw the graph, but at this stage in your career, forget that. Okay, N, use power series. Okay, oh, just cross out O. We're not going to do it this year because you're special. P, who put P on the board? I want to know. Who put P on the board? I mean, not P-E-E, the letter P. Who put the letter P on the board? That was exactly the same example as I did on the first day when we learned friend.
I was taking the hit for the class.
Okay, you got one question. Which one are you gonna ask? Okay, let's do cute. Well, I see a radical there. What do you think you're gonna do? Multiply by rhymes with conjugate. Help me. I thought you guys were actually good students. Okay, we're done. We gotta learn something. Anyway, this is what's probably gonna happen tomorrow. You come to class. I don't know what's gonna happen. I don't know. We're so far behind. It's like ridiculous. We went through so many Plan Bs this year. Now we're behind. You know, back in what was the year we learned so much? It was 1993. In 1990, no, because that's when I first started making the worksheets. That's why. You know how much we learned in here? It was just incredible. It's like, oh gosh. Okay, we got 15 minutes. Okay, that's better than period 6. Okay, now why is calculus? So why did we learn calculus? Well, now I already told you, but some of you forgot. Okay, let's say this is the graph of time versus position. Now you guys in physics should already know this, right? If this is the graph of position, what does the slope of the tangent line tell you? The instantaneous velocity. And those of you who are going to take physics next year, I expect you to dominate because you're going to know calculus. This is time versus velocity. If this is the graph of the velocity right here, what does this area tell you? The distance traveled. Now these are like two of the most important problems in calculus. How do you compute the slope of the tangent line? How do you compute this area? Now I already taught you how to compute this area, right? This was on the last test. Remember, you break it up into rectangles. Remember that thing? And then you take the limit as the number of rectangles approaches infinity. We did this last chapter. Anyway, this was the class I showed you how to do this on your calculator also, right? Remember Math 9? Okay, take out your calculator. I guess that was period 4 then. Okay, suppose you have a graph. Here's the graph. One hump of the graph, y equals sine x. How do you compute this area right there? Well, your calculator can do it. Okay, TI people, you go Math 9. What does it say? It either says this, numeric integral. How many people see this?
Oh, we
I know
did
we
this.
did do this. Sorry.
We did this. How come almost every person said no, we didn't do it? Okay, now, your calculator can also compute the slope of the tangent line. Okay, let's say this is the graph of sine x then here. Y equals sine x. Right here, when x is 1, how do you compute the slope of the tangent line? Okay, now, TI people, you go Math 8.
Oh, Math
Now, what happens when you press Math 8? What does it say on your screen?
Integrate.
Okay, it either says n deriv, this would be the old TI, or it says d something of something at x equals something, correct? Who sees this?
This box equals something.
Okay, so if you just have the old TI, then you just type in the function, sine x, you better be in radian mode, comma x, comma 1. This will tell you the slope of the tangent line when x is 1 for this curve right there. Now, if you see this x, then you put sine x here when x is 1. Now, prism people, you press the math button, I think you have something like this, right? D over dx. Psycho? Press the math button. Okay, exit. Run matrix. Okay, press the math button. No, not the matrix button. Oh, there, d over dx. There you go, and fill it in. Oh, yours looks like this. It already has the x already. So all you gotta do is type in sine x, and then what does it say? Oh, it has the line. Line at x equal 1. So what this is gonna do, it's gonna tell you exactly what the slope is right at that point. And what does it say? 0.5 something, right? 0.540? Yeah, that's the slope. So your calculator can do it because it's programmed, but now you're gonna have to be able to figure this out without a calculator. How do you compute the slope of the tangent line? Well, all of calculus is based on this concept right here. Okay, here we go. Now we only got, oh my gosh, we're in a heap of trouble. Okay, this represents any function, y equal f of x. Now this is our goal, right here at this point. Right there at that point. I want to compute the slope of the tangent line because that's super important. That's going to tell me the instantaneous velocity. Now how the heck do I do this? Well, now there are certain, there's a reason why you take geometry before you take calculus, because there's concepts you need to know. If I have a circle, what kind of line is that called if it intersects a circle at just one point? That's called a tangent line. Can you see the similarity between that and this? Or there's no similarity at all. What kind of line is that called? That's called a secant line. That's like this. See, this would be called a secant line. But if it's just at that one point there, we call that a tangent line. This is called, some people are like, what? Come on, this is simple geometry. Tangent line intersects a circle at one point, a secant line intersects it at 2 points. But then we can generalize it not to just to circles, but to any graph, any curve. Anyway, this is our goal. We need to find the slope of this tangent line. How do we do it, Mr. Park? Well, here we go. What are the coordinates at this point? If this is x right here? X, comma. I'll just tell you, since you're not responding again. F of x. I thought it was x, y. Yeah, but y equals f of x. Now we're going to move h units to the right. So what's that? X plus h. Go up to the curve. What are the coordinates at this point then? X plus h, comma, f of x plus h. So what kind of line is this called right here? This is called a secant line. How do I compute the slope of this secant line? Y minus y over x minus x. That's how you compute slope, right? What is y minus y? F of x plus x, h minus f of x, all over x minus x. What is x plus h minus x? H. Hey, you somebody! What do we call this thing? That we've been studying since Algebra 2. Remember when we did it in the second quarter? I told you all of calculus is based on this thing right here. This is called the difference quotient. That's why you study it in Algebra 2 and pre-calculus. So when you get to calculus, you know what we're doing. And what does this difference quotient represent? The slope of the secant line. But we don't want the slope of the secant line. We want the slope of the tangent line. So how do we get from the slope of the secant line to the slope of the tangent line? Well, this is what we do. You take this point and you bring it closer and closer and closer and closer to that point. Because look, you start with this. Then if you bring this point in closer, then you get that. Then bring the point in closer, you get that. Bring it closer, that. Bring it closer, that. So the closer and closer you bring that point in, don't you get closer and closer to what the slope of the tangent line should be? So what's the mathematical way of saying, bring this point closer and closer and closer to this point? You take the limit
Take a limit.
as,
H approaches.
yeah, exactly, because look, this is the horizontal distance between the 2 points, right? If this point comes in closer, what happens to h?
Gets smaller.
It gets closer to 0. So if you take the limit as h approaches 0, that will give you the slope of the tangent line. And that is why if you don't write limit, you're in a heap of trouble. Because there's a big difference between this and that. This is the slope of the secant line. Or we call this the average rate of change. But if you take the limit as h approaches 0, you get the slope of the tangent line, or we call that the instantaneous rate of change. Now, you guys in physics, isn't there a big difference between the average velocity and the instantaneous velocity? There's a big difference between the two. Anyway, if you compute this limit, this is called the derivative. The derivative of a function tells you the slope of the tangent line. And all of calculus is based on this concept right here. And this is how we write the derivative. If this is the function, this is the derivative, f prime of x. So I'm going to box this because that's what you got to use on tonight's homework. So in the second quarter, all we did was compute the difference quotient. We just simplified it. But now we're going to take the limit as h approaches 0, which will give me the derivative. So let's look at a problem. What if I have f of x equals x squared? Now tonight's homework, I'm going to give you a function. You have to compute its derivative. All you got to do is just follow what I'm doing right here. Or look at the notes. Okay? This is how you compute the derivative, people. Okay, right here. You take the limit as h approaches 0 of f of x plus h. Now, how do you compute f of x plus h? What do you do? You take x plus h and you plug it into the function. So you get x plus h squared. So if you cannot even form the difference quotient, that's it already. It's all over. Minus f of x. What's f of x? X squared. And then you divide the whole critter by h. Like this. See, you did that part. The only thing different we're doing now is we're just taking the limit as h approaches 0. Okay, now, what happens when you compute a limit? What's the first thing you do? That's what we've been learning the last week.
Plug in the number.
You plug in the number. If I plug in 0 for h here and there, what do you get? 0 over 0. In fact, you know what? It's always going to be 0 over 0. So you have to know how to handle the 0 over 0 case. So what did we learn?
Multiply that.
Should I look for friend?
No.
Should I multiply by conjugate? No! I don't see trig functions. I don't see radicals. Just simplify the critter. So multiply it out. What do you want to do? Multiply this out or treat it as a difference of squares?
Difference is squares.
No. I think we should multiply it out. Because it just... And then, ooh, the next squares cancel out. And then can I factor out a h on the top? Yes. Ooh, the h's cancel out. Now can I plug in 0 for h and get something? And what do you get? 2x. There you go. 2x is the derivative of x squared. This tells you the slope of the tangent line. Let me show you how this works. Okay, y equal x squared. The graph is your basic everyday parabola, right? Vertex at the origin. Okay, here's the point. Here is the point 1, 1. Now, the other class told me in physics, what you guys did is to get the slope of the tangent line, you just eyeball it like that, right? And then you compute the slope of that line. That's baby food. Because now we can compute it exactly. So what is the slope of the tangent line right here at this point? Well, it's 2 times the x value. What is the x value at this point? Here, let me underline it for you. So what's 2 times that? 2, that's the slope of the tangent line, it's exactly 2. Because that's what the derivative tells you. The derivative basically is a formula that tells you the slope of the tangent line. Okay, what about here? Here is the point -2, 4. Here is the tangent line. What's the slope of it? 2 times the x coordinate. Here, let me underline the x coordinate for you. 2 times -2 is -4. Does that make sense? It's -4?
Yeah.
Yeah. Okay, here's another point. Here's the point 3, 9. Ow. 9. Somebody's gonna pay for that. Here's the slope of the tangent line. What's the slope? 2 times the x coordinate. Okay, let me circle the x coordinate for you. It's 6. It's pretty steep, yeah, that makes sense. What about right here at the vertex, at the origin? This is the vertex. What is 2 times the x value? 0. Does it make sense that the slope of the tangent line is 0 right at the vertex? Yeah. In fact, this is an important thing in calculus, people. Look, when you have a graph, like here, here's a local maximum. What can you say about the slope of the tangent line? It's 0. What the heck is that? What about at this local minimum right here? What can you say about the slope? It's 0. So that, remember how in the second quarter we used our graphing calculator to calculate the max and the min? But now we don't even need that anymore. All you gotta do is compute the derivative and figure out when it's 0, because the derivative tells you what the slope is. You guys understand that? The derivative just tells you the slope of the tangent line. All of calculus is based on this single concept right here. So tonight's homework, all that's going to happen is I'm just going to give you a different function. Instead of x squared, I think I gave you x cubed. I gave you 1 over x and the square root of x, correct? You have to compute the derivative. So just do this difference quotient, compute the limit, and you can get the answer. So, see, this is the difference between BC and AB. In BC, you got to know this stuff already. In AB, you're probably going to review pre-calculus for a month before you even start this. That's the difference. Okay, we're done. So tomorrow, report to class. I'm not sure what's going to happen. You guys might be too tired to even do anything. Right? Who's taking the test? Oh, only a few people. Wait, did you have an AP exam? What? Yesterday. Friday.
On Friday and Tuesday.
Oh, but then you have to take the...
I take the retake next Wednesday.
You know the retake is harder, right?
Yeah, I just want to get my money back for Sunday. Because it's the AP English one. You know that extra.